Hi, I'm biological anthropologist Jonathan Marks, and I'm here to talk about the scientific revolution. The scientific revolution actually had nothing to do with former NFL quarterbacks Colin Kaepernick and Cam Newton, but rather with Nicholas Copernicus and Isaac Newton. Scientific revolution is a strange name because it was a revolution that took like a century and a half. So it was a revolution in slow motion, an intellectual revolution. And to understand it, we're going to have to look at it culturally and to get inside the natives' heads, so to speak. In this case, the native is a medieval European scholar. Europe is a bit of an intellectual backwater. The real intellectual activity is going on in the Arab world, with alchemy and algebra, words that don't even exist yet in Europe. But Europeans have a coherent understanding of the world that was basically a consensus based on the classical works of Aristotle and Ptolemy. This world was a geocentric solar system, with the Earth below and the sky above. Question number 1, why do things move? 1A, why do they move downwards? Or what is falling? Things are made up of a composite of the 4 elements: fire, air, water, and earth. Fire is light and goes up. Earth is heavy and goes down. Air and water are in the middle. And things fall according to how much of each of these they are composed of. Something falling is attempting to reach its natural place according to how much gravity or levity it possesses. What's it falling towards? The center of the Earth and universe, presumably. 1B. We have now explained why things move up or down. But why do things move sideways? 3 reasons. 1, they will it. 2, they were struck by something. And 3, they're attached to something moving. Question number 2. What's going on in the sky? Now, this is the result of thousands of years of Eurasians having nothing better to do at night than stare at the sky. There is motion in the sky. You have the stars at night, which always remain in the same positions relative to one another, even as they go around the North Star over the course of an evening. The ancient Babylonians didn't have time-lapse photography, but if they had it, it would have looked like this. And then there are 5 stars that behave a bit differently because they actually do change position relative to the real stars over the course of weeks and months. And we will call them the wanderers or planets: Mercury, Venus, Mars, Jupiter, and Saturn. The behavior of all of these things is totally predictable from thousands of years of watching them, and consequently they are concerned somehow with the regularities of life. But then there are irregular celestial phenomena, like comets and meteors, which are omens, and somewhere in the middle are eclipses. And question number 3, how is the universe built? Clearly the moon goes around the Earth, and it doesn't seem to be alive, and nothing seems to be colliding with it. So it must be moving because it is attached to something moving. The moon is embedded within a celestial sphere. The sun is embedded in a sphere a bit further out. The planets each have their spheres, and the stars occupy the farthest sphere. This is a 2-dimensional representation of a 3D model, but there are important differences between the sublunar sphere, or Earth, and the heavenly spheres, or the sky. In the sky, things are eternal. On Earth, they decay and reform. In the sky, things tend to move in circles. On Earth, they move in lines. The things in the sky are beautiful and glowing and pristine solid orbs. Things on Earth look like shit. This is a system that makes sense, and certainly sense enough for the people thinking within this system. The scientific revolution, defined essentially for physics and astronomy, involved breaking this system down and reconceptualizing movement and inventing outer space. When I say inventing outer space, there's no place in this system for floating balls circling around one another. That's the radical new idea. To tear the old system down, we'd like to turn to Copernicus first, in 1543, who suggests that the Earth may not be the center of the solar system, but our recorded observations make just as much sense with the sun in the middle. The most obvious problem is that Earth is heavy, and so Earth doesn't move. If a mountain is on fire, the fire rises and the mountain stays still. That's our experience. Little lights in the sky are what move. And they do it because they're attached to a moving sphere. The first thing to notice about the Copernican model is that it's actually very conservative compared to the Ptolemaic or geocentric model. All he's really done is to switch the positions of the Earth and Sun. And he is actually still working with celestial spheres. The outermost sphere is labeled the unmoving sphere of the fixed stars. This is not a conception of infinite space. He believed all the stars were the same distance from the Earth and attached to a sphere. So the first thing we'll do is get rid of that. The legend reads, "This orb of stars, fixed infinitely up, extends itself in altitude spherically, and is therefore immovable, the palace of felicity garnished with perpetual shining glorious lights innumerable, far excelling our sun both in quantity and quality, the very court of celestial angels, devoid of grief, and replenished with perfect endless joy, the habitacle for the elect." That leaves us by the late 1500s with three obstacles for the heliocentric Copernican solar system. The first is, we know things can go around the Earth. The moon definitely does. But nothing else has ever been seen to have something going around it. Until Galileo adapts a recent invention for looking into neighbors' bedrooms, the telescope, and looks instead at the planet Jupiter, and becomes the first person to see moons going around Jupiter. And he publishes on it in 1610. Second problem, heaven or the sky and Earth are completely different. The sky is eternal. Every star that ever was is still there and exactly where it's supposed to be. Until the Danish astronomer Tycho Brahe looks at the constellation Cassiopeia and sees a new star, super bright, but in a very familiar position in the sky. He calls the new star a nova, and suddenly the sky is a lot less eternal than it used to be. Heavenly bodies are perfectly round and beautiful, but Galileo looks at the moon and sees that it has mountains and craters, just like the Earth. Things in the sky move in circles, but on Earth in lines? Actually, neither is true. They move both in more complicated paths, like ellipses and parabolas, whose math is now getting worked out by mathematicians like Descartes. More importantly, if you jump up, you fall back down to Earth because the Earth is the center of things, and how heavy or light you are determines how fast you fall towards your natural place. But if the Earth isn't the center of things and the sun is, then if you jump up, why do you fall back to Earth and not fall back to the sun? If the Earth isn't the center of the universe and the thing that other things fall toward, then we need a new theory of gravity. Spoiler alert, that will come in the 1680s from Isaac Newton. Gravity is a relationship between two objects, not a property of either. And exactly the same laws govern the falling of apples on Earth as planets in space. And suddenly we now have a theory by which floating balls can move themselves by virtue of the inherent attraction of their masses acting in proportion to the square of the distance between them. Right, Isaac? Except, of course, that they're all going around the sun, not the Earth. But here's what European scholars did over the course of the 1600s. They invented outer space. Previously, there was Earth and there was sky, and sky was presumably the same as heaven. Now it's like all sky and Earth embedded within it. And those other planets and stars are no longer lights, but distant places. Previously, the moon was a thing, not a place. So visiting the moon would be like visiting a light bulb. Now, the earliest science fiction could imagine visiting there. And there were theological implications as well, which religion would adapt to. Heaven was no longer in the sky, but became a more spiritual rather than physical place. There was also a possibly happy theological consequence of the Copernican system, since according to Dante, the center of the Earth and the solar system is hell. And for what it's worth, with the sun at the center, we now seem to be farther away from all that. Most significantly, though, it validated an image of God that had been gaining ascendancy in Christian theology for a few centuries. In ancient times, God had been understood to be like a king, someone who is great and powerful, but most importantly is above the law. But another view of God had emerged that was a bit different, namely God as an all-wise creator, a kindly watchmaker, a divine architect. This Christian God had somewhat different properties, in that he, and God was still a he, was the perfect creator and runs the world through his laws, which we call nature. A king does whatever he wants. Nature doesn't. God made the world to run a certain way. A king is not bound by rationality, but an engineer is. God is now a perfect and rational creator who created a perfect and rational world. Our job as scientists is to figure out those laws, to figure out how this great machine runs, and in so doing, essentially to read the mind of God. Seeing God as rational and as the creator of laws permitted the development of certain guidelines for understanding natural law or the mind of God. For example, simplicity and efficiency are rational, so that is presumably the way God works. And we look back to a medieval philosopher named William of Ockham, who argued that complex assumptions are like unwanted facial hair and should be shaved off. And the message of science as a way to read God's mind remained immensely powerful theologically, because the biggest revolution in science was that if you said, I want to know things that only God knows, in the year 1600, they would have burned you at the stake. But in the year 1700, they would go, cool. And that is precisely the way in which the human genome sequence was publicly presented in the year 2000. Today we are learning the language in which God created life. In the year 1600, that would have been arrogant and heretical. Making it normative permitted a cultural, intellectual, scientific revolution.